Hello students. Today I want to teach you how to use the Pythagorean Theorem to solve different parts of a right triangle. You've had this before, but this is going to take it a couple steps, in a more advanced level. But let's first write down the Pythagorean Theorem. The Pythagorean Theorem says that we're going to use c for the hypotenuse, that c squared is equal to the other two sides, each of which is squared, added together. Now I'd like you to get in the habit of putting the hypotenuse on the left side, and there's a reason for that we'll get to in a couple minutes. But on your notes, I'm going to do just a few of these. I ask that you complete the rest on your own. Number one, you want to always be able to tell the hypotenuse. The hypotenuse is the side with the biggest number. In this case, it's 10, but another way to know is that it's the side across from the right angle. And that's really what I'd like you to realize, that the hypotenuse is always across from the right angle. So, again, put the hypotenuse on the left side. 10 squared is going to be this side squared plus this side squared. And we're trying to find that side. It doesn't matter which order you put those in, but again, I do want you to put the hypotenuse on the left side. So 10 squared is 100, 8 squared is 64, and we'll subtract 64 from both sides, and so 100 minus 64 is 36. And now we're down to x squared. And what we want to do, I hope it's obvious now after all that we've done, is we're going to take the square root of both sides. So if we take the square root of both sides, we get that side x is 6 units long. And that's it. Now, number 4, we're solving for the hypotenuse. Again, think of the side. It's always going to be the longest side, and it's the side across from the right angle. So we're going to say x squared is equal to 3 squared plus 4 squared. So x squared, which is the hypotenuse squared, is equal to 9 plus 16. 9 plus 16 is 25, so you can do that in your head. The square root of both sides, x would be 5. And that's examples 1 and 4. Okay, continuing on, let's look at problems 8 and 9. Now in problem 8, it's the same deal, except one of the sides is in radical form. And if you're dealing with radicals, you always want to put them in the simplest radical form, which means if you end up with the square root of 24, let's say, you're going to break that down into the square root of 4 times the square root of 6, and so on. But we established the Pythagorean theorem. Again, always put the hypotenuse, again, it's the side across from the right angle, on the left side. So we're going to say 4 squared is equal, and I would like you to put the radical in parentheses. The square root of 7 squared. In fact, let's pause right now. The square root of 7 squared is what number? Well, it's the number 7, is it not? Because remember, the square root and squaring undo each other. And then we've got x squared over here. So we have 16. Square root of 7 squared is 7 plus x squared. Subtract 7 from both sides, we have 9. And then we'll take the square root of both sides. The square root of 9 is 3. Whoops, that's not, 3 should be there, and an x right there. Okay, now in number 9, you're being asked a different thing. You're being asked to decide, is this a right triangle? Notice that there is no little marker there. It kind of looks like it is. But here's the thing. If it is a right triangle, then this longest side squared would equal this squared plus that squared. And so what you're doing is you're checking it out. And if it turns out that what we believe would be the hypotenuse squared equals that squared plus that squared, then we can conclude that yes, it is a right triangle. So let's do it. Over on the left, I'm going to put 2 times the square root of 3, and I'm going to put in parentheses squared. Is that equal to 2 squared plus 2 square roots of 2 squared? Question mark. I don't know yet. Now, this is the only tricky part. I want to square 2 square roots of 3, but keep in mind, 2 squared is the number 4 times, all right, the square root of 3 squared is the number 3, because again, square rooting and squaring are inverse operations. So 2 square roots of 3 squared is actually the number 4 times 3, which we know is 12, but we'll deal with that in a moment. 2 squared here is 4, plus, again, over here, 2 square roots of 2 squared is 4 times the square root of 2 squared is 2. So on the left we have 4 times 3 is 12. Is that equal to 4 plus 4 times 2 is 8? Question mark. And it does equal, therefore, it is a right triangle, because we've taken that squared each thing, added them together, and they do equal each other. So that's problems 8 and 9. Okay, let's do the last 2 examples that I want to do for you. Number 11, we're being asked to decide, is this a right triangle? Is it an obtuse triangle? Or is it an acute triangle? And it's very similar to the last one that we did. You're going to take the largest side, in this case it's 16, you're going to square it. And then you're going to say, okay, in relation to these other 2 sides, squared, what do we have? Now, if this number squared is equal to these 2 squared, it is a right triangle. If, on the other hand, it's greater than, it's going to be obtuse. Or if this number squared is less than the sum of those, it's going to be acute. And the only way you'll find out is to plug it in. Now, one thing that may not have been obvious, I just assume that this number is smaller than that. You can't always go by the picture, but ask yourself, the square root of 58, is that a bigger or smaller number than 16? Well, the square root of 64 is the number 8, so obviously this is smaller than it. So yes, this would have to be the hypotenuse if it is in fact a right triangle. So again, always put that on the left. And I've done the calculator work earlier, so 16 squared is the number 256. Now, what is that in relation to the sum of these? Well, the square root of 58 squared is just the number 58. And 14 squared is 196. So 58 plus 196, it turns out to be 254. So the number 256, since it's greater than the number 254, that means this is an obtuse triangle. So again, real quickly, if it equaled each other, it would be a right triangle. If this was smaller than that, it would be acute. But since the left side is greater than that, it will be obtuse. Now, I want to go to the problems, the last section, finding the area of a triangle. And you may want to remember, or you may remember, let's absolutely remember, that the area of a triangle is 1/2 the base times the height. 1/2 the base times the height. Well, let's look at this particular triangle. We can tell it's an isosceles triangle because these 2 sides are the same. And because this is, you really haven't gotten to this point yet, but you could probably guess, this is an angle bisector, which means this side and that side are the same. So if that side is 7.8 and that side is 7.8, then the base is equal to 15.6. Now notice the directions want you to round it off to the 10th spot. So keep that in mind. So this is the base. All right, what's the height? The height is right here. Well, how are we going to get the height? Well, Pythagorean Theorem. So let's isolate that right side to find the height. This leg is 7.8 and the hypotenuse is 9. So we'll say that 9 squared is equal to h squared plus 7.8 squared. So we get 81 is equal to h squared plus, now let's see, 7.8 squared was 60.84. So we're going to subtract 60.84 from the number 81, and we get that 20.16 is the height squared. Okay, at this point, what do? We take the square root of both sides. The square root of 20.16 rounded off is 4.5. So here's the height, there's the base. Now let's plug it into the area formula. So the area of that triangle is 1/2, since we've got decimals here, I'm going to call 1/2 0.5, times the base, 15.6, times the height, 4.5. And when you multiply all that stuff together, you get that the area is 35.1 units squared. And since we're finding area, I would like your answers to always be in units squared. And that should be sufficient to help you do the rest of the problems. And that's it for Pythagorean Theorem.